くりレ夢ムです。ゆっくりマリサだぜ。
Hi, Raimo. Hi, Marissa. Hey guys. The hidden case for pi equals 6.28.
ゆっくりしていってね。
Section 1. Hook. What if one of the most famous numbers in human history was the wrong number? Not wrong like someone made a mistake. Wrong like we picked up the right tool, but grabbed it by the wrong end, and then taught every student on the planet to use it that way for over 2,000 years. There's a growing movement among mathematicians, physicists, and educators who believe that pi 3.14159, the number you learned in school, the number on your coffee mugs, the number people tattoo on their forearms, is not actually the most natural way to measure a circle. They believe the real number should be 6.28318, exactly. Double, in their case. It's surprisingly hard to argue with .so. Here's the question. Did the ancient Greeks accidentally send mathematics down the wrong path? And what would the world look like if we'd chosen differently? Section 2. The story begins. To understand this mystery, we need to go back. Way back. Ancient Greece. Around 250 BC. A mathematician named Archimedes is staring at circles, trying to figure out their secret. He wants to know, what is the relationship between a circle's width and the distance around its edge? He measures. He calculates. He discovers that no matter how big or small the circle is, the distance around it, the circumference, is always the same number of times longer than the width, the diameter. That ratio is approximately 3.14. And that number got passed down. Generation to generation. Culture to culture. It was given the Greek letter pi in the 1700s, and it became one of the most famous constants in all of mathematics. Here's the thing, though. Nobody really questioned the choice. They asked what the ratio was. But they never seriously asked, is this the right ratio to be using? That question didn't get asked, loudly at least, until the year 2001. That's when a mathematician named Bob Pillai published an article with a title that turned a lot of heads. That he called it, Pi is Wrong. And within the math community, it quietly caused a small earthquake. Pillai wasn't saying the number 3.14159 is incorrect. He was saying that we chose to define pi using the diameter of a circle, the distance all the way across, when we should have used the radius, the distance from the center to the edge. Why does that matter? Because virtually everything in mathematics and physics is naturally defined using the radius, not the diameter. When you write the equation for a circle's area, you use the radius. When you write the equation for a wave, you use the radius. When you describe rotation, angles, orbits, pendulums, electrical signals, everything uses the radius. The diameter barely shows up at all. So Pillai asked, what if we built our circle constant around the radius instead? The answer is exactly 6.28318, or as some now call it, tau, written as the Greek letter tau. And once you start looking at mathematics through that lens, something genuinely strange happens. Everything gets simpler. Section 3. The evidence. Let's look at the evidence. Because the case for tau isn't just philosophical. It shows up in the actual math, again and again. First piece of evidence. Angles. If you've ever taken a geometry class, you've dealt with radians. Radians are the natural unit for measuring angles in mathematics, and they're based on the radius of a circle. Here's the thing. A full circle, one complete rotation, is 2 pi radians, not pi. Not one clean unit. 2 pi. Always. Every time. So when students learn that a full rotation is 2 pi, a half rotation is pi, a quarter rotation is pi/2, they're constantly dividing and multiplying by 2. Just to get back to something intuitive. But if you use tau instead, where tau equals 2 pi, suddenly a full rotation is just tau. One whole circle equals 1 tau. A half circle is tau/2. A quarter is tau/4. The fractions now mean what they say. Half a circle is half of tau. It's obvious. It's clean. It's what students actually expect before they learn the real version and get confused. At first, this seems like a minor convenience. But keep watching, because it goes much deeper. Second piece of evidence. Euler's identity. We talked about this in our last investigation. Euler's famous equation, often called the most beautiful in all of mathematics. e to the power of I pi plus 1 equals 0. Mathematicians love it. Posters of it are sold on Amazon. Nerds get it tattooed. But here's something almost nobody mentions. In its original form, before it gets simplified, the equation says something even more interesting. E to the power of I times tau equals 1.1. Complete rotation in the complex plane brings you back to exactly 1. That's what the equation is saying. A full turn, back to where you started. With pi, you need the +1 equals 0 adjustment to make it work. You're catching it at the halfway point, half a rotation, and correcting for it. With tau, the equation describes one full circle, one complete journey. And it lands exactly where you'd expect. That it's not that the pi version is wrong. It's that the tau version is, arguably, more natural, more complete, less like a workaround. Then investigators discovered something unexpected. Third piece of evidence, the normal distribution. This is the bell curve, the most important shape in all of statistics. It shows up in IQ scores, height measurements, manufacturing tolerances, financial markets. Everywhere human data clusters around an average. And when you write the formula for the normal distribution, the actual mathematical expression, there's a factor that appears in the denominator, square root of 2 pi, not pi, 2 pi. In the most famous statistical formula in the world, the 2 pi appears naturally. Swap in tau, and that ugly 2 pi becomes just tau. Clean. Obvious. One symbol where there used to be 2. This is not a coincidence. It's because the normal distribution is fundamentally about rotations and circles in a multidimensional sense. And those things naturally want tau, not pi. Fourth piece of evidence. Physics. Planck's constant. One of the most important numbers in quantum mechanics. It determines the relationship between a photon's energy and its frequency. It appears constantly throughout modern physics. But in most actual calculations, physicists don't use Planck's constant directly. They use what's called h-bar, Planck's constant divided by 2 pi. Why divided by 2 pi? Because wave physics and quantum mechanics is fundamentally about waves, naturally operates on full rotations. The 2 pi is always there because the physics wants a full cycle. If you define things in terms of tau from the beginning, h-bar would just be Planck's constant divided by tau. Same idea, but one symbol instead of a fraction. The 2 pi appears so often in physics that it essentially has its own nickname. That's the hidden truth here. It's not that pi is wrong. It's that 2 pi is the real star of the show, and we've been making students write it out longhand every single time. Where does that leave us? Section 4. Theories. There are 3 major positions in this strange mathematical case, and they don't all agree. Theory 1. Tau is genuinely better, and we made a historical mistake. This is the position of the so-called Taoist camp. Mathematicians like Michael Hartle, who in 2010 published the Tau Manifesto, a detailed, rigorous argument for replacing pi with tau. Their claim is simple. If you were designing mathematics from scratch, knowing what we know now, you would define the circle constant using the radius. You would get 6.28318, and you would call it something, maybe tau, maybe something else. But you would not use 3.14. The evidence on their side is compelling. The 2 pi shows up constantly. The angle system becomes immediately intuitive. Dozens of formulas simplify. Students consistently struggle with radians in ways they wouldn't if tau were the standard. Hartle called March 6.28, June 28th, Tau Day. Some universities and math departments now celebrate it alongside Pi Day. The weakness of this theory? It doesn't matter how right you are if nobody changes. The mathematical world runs on pi. Billions of textbooks, calculators, software libraries, engineering tools, all built around 3.14159. Switching would cost an enormous amount, for a benefit that is, many would say, mostly cosmetic. Theory 2. It's a matter of convention, not truth. This is the position of most working mathematicians. And it sounds unsatisfying, but it's intellectually honest. The number 3.14159 and the number 6.28318 are both perfectly valid ways to describe properties of a circle. Neither one is the true circle constant the way that, say, E or the speed of light are fixed truths. They're both just ratios. We chose one. We could have chosen the other. Mathematicians in this camp point out that mathematics is full of conventions that could have gone differently. We count from 0 or from 1 depending on context. We define logarithms with different bases for different purposes. Choices get made, and then the field moves on. The theory says, yes, Tau might be more elegant in many cases, but elegance is subjective, and pi has been perfectly fine for 2,000 years. The mystery here isn't really a mystery. It's just a historical choice that happened to stick. The weakness? It doesn't explain why 2 pi appears so relentlessly throughout physics and mathematics. If the choice were truly arbitrary, you'd expect pi and 2 pi to show up equally often. But they don't. 2 pi dominates. That feels like a signal, not a coincidence. Theory 3. Both numbers matter, for different reasons. That a third camp, smaller but interesting, argues that pi and tau are both genuinely important, and that the which one is right framing is the wrong question entirely. They point out that pi is the natural constant for area. The area of a circle is pi times the radius squared. Write it with tau, and you get tau/2 times the radius squared, which is actually less clean. So for area calculations, pi genuinely wins. Meanwhile, tau dominates for circumference, rotation, and wave calculations. The hidden truth, this theory suggests, is that circles have 2 fundamental properties, area and arc, and each one has its own natural constant. We just happen to name one of them and ignore the other for most of history. Section 5. The most likely answer. Let's be honest about what we actually know here. The "it's just convention" theory is probably the most technically accurate. Neither 3.14 nor 6.28 is more fundamentally true, in the way that the speed of light is true. They're both ratios, both valid. Mathematics works equally well with either one. But here's where it gets interesting. The question isn't whether tau is mathematically more correct. The question is whether tau is more natural, whether it fits the way mathematics actually grows and breathes, and the evidence strongly suggests it does. Think about what we found in the investigation. The 2 pi appears in the formula for a full rotation. It appears in the normal distribution. It appears in quantum mechanics Planck constant. It appears in Euler's identity in its more complete form. It appears in Fourier transforms, the math behind digital audio, image compression, and wireless signals. It appears in wave equations, orbital mechanics, and alternating current calculations. In every one of these cases, someone took a formula, saw a 2 pi, and just wrote it out. Because that's the convention. Because pi was defined without the 2, and so the 2 has to travel everywhere alongside it. Like a constant companion nobody ever introduced. That's not a coincidence. It's a pattern, and patterns in mathematics are evidence. The most defensible conclusion is this: pi is not wrong. But it's the right answer to a slightly wrong question. Archimedes asked, what is the ratio of the circumference to the diameter? The more natural question, given how mathematics actually works, would have been, what is the ratio of the circumference to the radius? Same circle, same relationship. Different question, different answer, and the answer to the better question is tau. Does this mean we should rewrite every textbook? Probably not. The cost is too high, and pi works fine as a tool. But should we teach students that 2 pi is a full rotation and make it intuitive? Absolutely. Some universities are already doing exactly that, teaching tau alongside pi in introductory calculus. Not replacing pi, just giving students the full picture, and that's something. Because for 2,000 years, students have been confused by the same thing. A half circle is pi radians? Why? That's not half of anything obvious. With tau, the answer is immediate. A half circle is tau/2. Half of the thing. Done. One change. Centuries of confusion. Solved. Section 6. Conclusion. Here's what strikes me most about this case. Archimedes was a genius. One of the greatest mathematical minds who ever lived. He was working around 250 BC with no computers, no calculators, no algebra as we know it. And he figured out the ratio of a circle's circumference to its diameter to remarkable precision. That he wasn't wrong. He was brilliant, but he was working with the tools and the questions available to him. The diameter was easy to measure physically. You stretch a string across the middle. The radius is an abstraction, the distance from a center point to the edge. In 250 BC, that's a harder thing to grab onto. So he used the diameter. And that choice, made for completely practical, understandable reasons, got locked in. For over 2,000 years. Across every culture, every language, every civilization that inherited Greek mathematics, and every student since then, learning that a full rotation is 2 pi radians, has had to carry that historical luggage. That's not a scandal. That's just how knowledge works. We build on what we inherit. We don't always go back and ask whether the foundation was the best possible choice. But here's the strange thing. We can go back. We can ask. And when we do, the answer is at least a little surprising. The number on the coffee mugs. It might not be the most natural way to measure a circle. There's another number, hiding in plain sight, twice as large, that fits the actual mathematics more cleanly. 0.6.28318. Touted it doesn't have its own emoji yet. Most calculators don't have a Tau button. Pi Day, March 14th, is a cultural institution. Tau Day, June 28th, is celebrated mainly by math enthusiasts with a taste for irony. But the investigation is ongoing. More textbooks are asking the question. More students are learning about Tau. The case is being reopened, and maybe that's the most unsettling part of this documentary. Not that pi is wrong, but that a number this famous, this embedded in human culture, this tattooed onto people's skin, might have a twin that was always more natural than a twin we've been writing as 2 pi this whole time without realizing what we were looking at. So next time someone says Happy Pi Day, just think about it. What if the real celebration was always 6 weeks later?